Thank you, Heather, for that great introduction, and thank you all for coming tonight to this talk. I want to start by saying I am not a client scientist. I actually am a learning scientist. I work in education primarily, and so I'm going to be telling you a little bit about some of the work I've done in environmental and climate education. But I also do a lot of sort of methodological work and a lot of policy analysis. I'm going to tell you a little bit about where that has intersected with climate and environmental stuff as well. But I wasn't sure sort of who the audience for this would be, so I wanted to start just with a little bit of basic background. I think this will probably be familiar to most of you, but we'll get through that part pretty quick, and then I'll get to the parts that are more about my research. So I think we all know that climate change is a global phenomenon, and it's a global phenomenon that's due to increased heating. Has two primary causes. One is human emissions, so primarily burning of fossil fuels. And the other is the removal of carbon sinks, forests, alterations to the ocean, that sort of thing. Climate change mitigation is things that address these sort of root causes, things like reducing emissions or reforesting deforested areas. Right. And for the most part, that's the last I'm going to say about mitigation, because most of this talk is really going to focus on adaptation. And adaptation is essentially the things that we do at a local level to deal with the effects of climate change that are already happening. So things like planting shade trees to deal with increased sensible heat, or creating sort of public cooling options for when temperatures are excessive. Adaptation also covers individual adaptations, like people just changing their clothing, wearing more sunscreen, wearing hats, that kind of thing. Right? So that's sort of the part of climate change that I'm going to be talking about tonight. So while climate change itself is a global phenomenon, and while mitigation really only can happen if it's happening at a kind of global scale, adaptations are local. They're really about specific places and the ways that climate change is going to affect those particular places. And in one of the projects that I work on has to do with analyzing the kinds of policies that we create to guide climate change adaptation. And in particular, I'm interested in studying policy ecosystems. And policy ecosystems are basically a way of thinking about policy in its sort of totality. So not just as sort of the emission of policy from governmental entities, but also the ways in which businesses are involved, communities through things like activism, bureaucratic structures, and of course, academia and scientific research as well, all of which sort of contribute to how we think about the development of policy. And in this sort of framework, there are a few different ways that we can think about how policies come to be. The first is through narratives, or what scholar Deborah Stone calls causal stories. Causal stories are things that take complex social issues and reconstruct them into simple problem statements. So for example, you might argue that climate change is caused by oil producers and large corporations. That's a causal story. It's a simple, easy narrative, right? Someone else could say, nope, climate change is caused by overconsumption in Western nations. It's also a causal story. It's a simple narrative about the causes of climate change, right? It's supply. No, it's demand. Right? And this changes how you would respond, right? Because if you think it's supply, then maybe your solution is tax emitters, right? If you think it's demand, maybe you think your solution is tax consumers, right? So the causal story that you choose dictates kind of how you think about the problem from a policy perspective, right? And this is the source of debate, right? This is often where policy debates start, because in choosing a particular causal story, you're eliminating a whole bunch of other options, basically. You're saying, no, this issue is about X. And that means anything that's not X is more or less excluded. It's not really thought about, right? Or if it is thought about, it's thought about as sort of secondary or lesser in some way. So that's sort of the beginnings of a policy discussion, is how you just choose to frame the problem to begin with. So the second piece of how policy works is through what I will call warrants. Essentially, these are the authoritative documents, right? These are the things that when we think about policy, we probably think about most often, right? The things that get written down and sort of codified in that way, right? So somebody sits down, they do a bunch of writing, and then they produce the thing. They produce the policy in some level, right? And this is, again, what we would typically think about when we think about policy, are these kinds of documents. And it is a really critical point because it's an emergence from that narrative of a kind of solution, right? Here's what we think the solution is to this problem as it's been articulated in a particular way. But there are at least two other ways that it's important to sort of think about policy. So one is through what I call enactments, right? So Michael Lipsky argues that really like where you see this is through what he calls street level bureaucrats, right? These are the people that actually interpret and enforce policy on a day-to-day basis. They're the ones that determine sort of how those policies get implemented, how they get enforced. They're the kind of gatekeepers of policy. Right? Because as we all know, whether it's law or policy, not everything is enforced equally, right? It might be enforced differently in different places at different times for different people, that kind of thing. But also there's a situatedness to a lot of policy decisions, right? And this can change even from gatekeeper to gatekeeper kind of thing. And lastly, policies are sort of visible through the experience of people that those policies affect, right? So when we're thinking about policy, we also have to think about not only sort of how they're created and how they're implemented, but also what the end result is, essentially, how they impact people. And again, the impacts can be varied, right? Because there's a number of different people, right? And different people might have very different experiences of the very same policy enforced in the very same way. Not to mention that people are situated in communities, and different communities might experience policies in different ways. So when I'm talking about policy, I'm talking about policy sort of as the totality of all these things, and that's what a policy ecosystem essentially is. It's the interactions of all of this. It's how all of these pieces kind of come together to produce that ecosystem for policy. So in one of the projects that I am currently working on, and this project is in its very, very early stages, so I'm presenting just some kind of initial pieces of this work, is a project analyzing climate change adaptation planning from that sort of lens of a policy ecosystem. And as of right now, I'm looking basically at two of the existing levels. One is as guidelines for policymakers, right? So this is sort of in that narrative camp where it's sort of framing out how policymakers should be thinking about climate change adaptation. And also adaptation plans themselves. So adaptation plans are being developed at all levels of government. A number of businesses even are starting to develop them. Lots of NGOs develop climate change adaptation plans, but primarily it's nations, states, municipalities, tribal groups, that sort of thing, are typically the ones who are developing these kind of plans. So at this stage of the project, this is sort of what I'm working with. Essentially, I'm taking all of these documents that people are producing and producing in increasing volume at this point. And I'm trying to analyze them, basically to take this huge volume of data, figure out a way to process it, and produce a kind of model that can help me get some sense of what's happening, at least in that part of the policy ecosystem. Right? And to do this, I'm basically essentially scraping this data from the web, because most of these are published policies, and even a lot of the guidelines, that kind of material is published. As of this stage in the project, I have, actually I think it's 6 now, I think I didn't quite update this slide enough. 6 guidelines for policymakers. 3 from the Intergovernmental Panel on Climate Change, the IPCC, which many of you have probably heard about in the news. They are the ones that publish these massive reports on climate change, but they also publish a lot of guidelines for how to think about climate change policy. in addition to ones from organizations like the World Bank or the World Health Organization, and then even some that are very specific or targeted, like I have one from the Great Lakes Indian Fish and Wildlife Commission, for example, that's about how policymakers should interface with tribal governments in thinking about climate change adaptation planning. In addition, I have about 182 separate adaptation plans. Adaptation plans can range quite a bit. Some of them are, 20 or 30 pages. Others are, 500 to 700 pages, depending on the scale of government that they're being developed at and just the level of detail that is being put in. About 67 are either national plans, or there's a few that are actually multinational. So there's a number of cases where things like river valleys or things where there might be multiple nations involved, they'll actually come together and produce plans for the region. But most are national. About 78 state and local plans, so these would be plans that would be produced like by US states or Canadian provinces, that sort of thing, or local plans, cities, counties, that sort of level. And I have about 37 tribal plans. Right now, all the tribal plans are from the US. I'm hoping to find more that are outside the US, but right now they're basically all in the US. Actually, there's a couple, I think, in Canada, but mostly in the US. They're from all over the globe, so this just gives you some sense of the geographic distribution. Again, North America is somewhat overrepresented. In part, that's because all the tribal plans, or almost all of them, are located in that part of the world, but otherwise relatively distributed across the globe. And I'm analyzing plans in 3 different languages. About 140 of them are published in English, 23 in Spanish, and 18 in French. There are, of course, plans that are written in other languages, but they're languages that I don't speak or don't know enough to actually interface with. And from what I have seen of how Spanish and French have been machine translated in this context, I am hesitant to machine translate those plans and analyze them, particularly if they were originally in Russian or Chinese or something that is probably even less good in terms of machine translation. But that being said, I'm hoping in the next few years that that translations get good enough that we could actually expand this sample considerably. Either that, or I'm hoping I can partner with some folks that actually know those languages well enough that we can bring other sources in. But due to the legacy of colonialism, English, Spanish, and French actually cover quite a bit of the globe, and so it does give me a fairly good sample of how climate change adaptation planning sort of looks relatively globally. And I'm analyzing all of these documents through the lens of quantitative ethnography, which is I won't go into the details for the purposes of this talk, but as an approach to taking sort of traditional kind of qualitative analysis approaches like ethnography or hermeneutics and unifying them with the kind of computational and quantitative approaches that allow us to do things at a scale that we can't do by just sitting down and reading things. So like I said, even at the scale of data that I'm working with right now, which is relatively small by big data standards, I'm still looking at tens and tens and tens of thousands of pages of documents, and every few months I add another dozen or so documents into this data set, so it's growing very rapidly as more and more plans are published, and so it's quickly getting beyond the scale at which anybody could sit down and actually read all of them. So it's really important to think about how we kind of merge the kind of close reading, sort of close kind of ethnographic analysis that you do in qualitative research with the kind of computational tools that are increasingly becoming available. And this is a particular approach that we've developed to do that kind of work. And what I did for this initial analysis was essentially look at some of the kind of key areas in which adaptation plans focus. So the first and most important is on hazards. Adaptation planning is all about how we deal with the hazards that are caused by climate change. And by hazards, we're basically talking about things that are due to either increasing temperatures or changes in precipitation. And so that can be things like increased sensible heat, which can cause the heat itself can be a hazard. If you have decreasing precipitation, then drought can be a significant hazard. Increasing precipitation, then you can then flooding and things like that can be a significant hazard. And of course, there are other hazards that are associated with this, things like wildfire increase, things like changes in biodiversity, which can cause literal plagues of locusts and things like that that will be sort of direct effects of climate change. And so again, adaptation planning is mostly about how do we adapt to these changes that are already undergoing. And then sort of around that, looking at a few sort of large-scale categories. So thinking about impacts on human health and also on environmental health, issues of food security and water security, and then issues of agriculture and energy. These are kind of the main sort of focuses. These are the kind of things that get whole chapters in adaptation planning. But critically, like I'm looking at these not just like, do they talk about them, because everybody talks about them, but actually how well integrated they are. Because it's actually really important in adaptation planning not to see all these things as isolated, even though they're often presented that way, right? Again, they often get their own chapters. It makes them seem somewhat disconnected. But in reality, like the quality of the planning often has to do with how well integrated they are, right? And so that's sort of one of the things that I started looking at. And I'm using a tool known as epistemic network analysis to do this kind of work. This is a QE tool, quantitative ethnography tool, that basically allows you to look at how different concepts appear in data and then model that so that you can compare across large numbers of cases. So for example, if I look at the model for all the national adaptation plans, one of the things that pops out pretty clearly is that there's a lot of connections from hazards to water security and agriculture, and of course between agriculture and water security. So one of the things that we see is that's somewhat overemphasized in a lot of national plans. Or not overemphasized, but it's more strongly emphasized than for other connections. And to some extent, that makes sense. This is probably going to be one of the more direct impacts outside of things like fires or sort of direct sensible heat. Some of the most direct impacts are going to be to agriculture. And so that's probably very central for a lot of sort of national planning groups. If we look at state and local plans, however, we actually see a little bit different pattern. State and local plans are less concerned with agriculture, although those connections are still there and are still pretty strong. But we actually see stronger connections, sort of more on the left side, hazards and water security particularly, but also more to human health and environmental health. And this makes some sense, particularly issues of human health, which in many cases are handled more locally and less nationally than environmental health tends to be a little bit everything. And if we look at tribal plans that are produced by tribal governments or other recognized tribal organizations, we see they're a little more similar to the kind of state and local plans, which makes sense because the scale is a little more similar there. But one thing we see is actually even stronger connections to food security in particular in tribal plans. And I think that's sort of a reflection of, these are often smaller groups, smaller communities, and particularly there's a lot of discussion in tribal plans about sort of traditional foodways and preserving traditional foodways, but also the buffer isn't there in many cases. And also tribal lands are often, at least in the US, which again, this is pretty much the whole sample, tribal lands in the US are often in much more climate sensitive areas, and that's in part because colonization basically pushed tribes into places that weren't being colonized. And then one of the nice things about this tool is that we can actually see, like, okay, well, this is nice. We can get a sense of, like, at this large scale, are there kind of differences across different types of plan. But we can actually sort of test to see whether those are statistically significant. Like, is this a pattern that's actually persisting across all this data, or is it just sort of, it looks different but isn't really different? So I won't again go into all the details, but we can essentially look at the sort of means of these different groups, compute confidence intervals, and test whether they're significantly different. And each one of those points, is essentially representing the kind of weighted structure of its associated network. So those three networks that I just showed you. So this is sort of, again, a very initial first attempt to sort of get a sense of like what's happening in adaptation plans kind of globally in these different contexts, and seeing those differences. As I noted, though, I was also interested in what are the guidelines that are being constructed for policymakers? Do they show sort of similar patterns or not? So if we look, for example, just at the IPCC reports, so there are 3 of them. There's actually been 6, but for reasons I won't bore everyone with, some of them are very, very hard to make machine readable. And so there's only 3 of them that I can actually work with in any meaningful way. But one of the things that you'll probably notice right away is actually agriculture is not quite as, it's connected to everything, but the strength of connection, which you can tell by the thickness and darkness of the lines, is a lot weaker in those plans. And if we look at, for example, those reports, which really are aimed at national governments, so they're aimed at sort of that scale, if we look at the difference between that network and the network for the sort of mean network for the national adaptation plans, they're pretty different. In fact, we can just subtract one from the other and then colorize based on where the connections are stronger. And as you can see, those 2 really strong connections we saw in the national plans are actually much stronger than what we're seeing in the guidelines for from the IPCC. And what that suggests to me, at least, is that the IPCC reports are not discussing sort of how agriculture integrates into this kind of planning anywhere near as much as a lot of the national governments actually care about it. And so that might be a potential sort of place where there's a mismatch between the policy guidelines and the ways in which the policies are actually being developed. Again, it's hard to say too much more at this point because this is a very preliminary study, and I haven't really gotten into the really nitty-gritty of the details yet. But I can say from reading a good amount of this that's fairly accurate. Like, there just isn't as much discussion of agriculture in those contexts as it integrates with a lot of the other issues. One thing I will say too is that this analysis is not something that I think will sort of solve all of our problems when it comes to thinking about how climate change adaptation policy is being developed globally. There's of course a whole bunch of ways in which this sort of analysis, even if I pick different things to look at, that kind of thing, we'll miss some stuff, things that are actually really important. Particularly, it misses things that are missing. Right? This kind of analysis is really good at telling you what is in these reports. It's not a very good way to find out what isn't. And so, for example, if you read through these IPCC reports, one of the things that they will point out is that actually there's a lot of aspects of adaptation that should be happening but aren't happening, right? So most observed adaptation is fragmented, small in scale, incremental, sector-specific. That sector-specific part is what I was really highlighting about, like, thinking of these things isolated rather than how they integrate. Designed to respond to current impacts or near-term risks, and focused more on planning rather than implementation. And again, if you think back to the sort of policy ecosystem framework that I was talking about, right, that implementation piece is there. I haven't started to get to that yet, but this is also a point that a lot of people are planning right now. Not a whole lot has actually happened with those plans yet, right? And so that's the other, one of the reasons it's really important to think beyond just the documentary evidence, which, I'm hoping to do in future phases of this project. The other thing, again, as I point out, is that, it's very hard to analyze what isn't there in any kind of systematic way. And that same report has pointed out that less attention has been paid to low regret adaptation options, especially at national and local levels, right? So the other thing that we often see in adaptation plans is these kind of sort of sweeping structural kind of things that need to happen, and they're not being presented from the perspective of what's it going to take to actually get it implemented. It's more like, this would be great if all this happened. And what that means is that oftentimes things that could be relatively easy to implement, relatively cheap to implement, relatively high impact and or relatively low risk may not even really make it much into the discussion, or maybe stuck in a footnote somewhere kind of thing, and not be part of kind of the main discussion. And part of the reason why sort of implementation is lagging has to do with financing. So more than 80% of the climate-related financing that's currently available is in the form of loans. Right? Loans that would have to be paid back. And that's a huge, huge barrier to doing sort of major infrastructural changes. Another huge barrier is that if you don't have organizations like USAID distributing funds from a wealthy country to less wealthy countries for exactly these kinds of projects, this becomes an even bigger problem. And in fact, I'm guessing that number is now going to go way up, because a lot of the sources of climate financing that did exist about 2 months ago are seriously threatened or already gone. Okay, so that's sort of one of the studies that I've been working on. Again, that one in its sort of very early stages. But now I want to change gears and talk a little bit about some of the education work that we're doing around climate change adaptation, in particular work that we're doing to support classroom learning about climate change. And so one of the projects that I've led in that area developed a simulation that we called iPlan. And I'm going to try and play you a brief video here, and hopefully it will work. So let's see.
iPlan is an educational game that lets players explore complex land use issues in their own communities. Players choose a location using a Google Maps interface, and iPlan creates a land use map using real geographic data. Based on the environmental and socioeconomic issues selected, iPlan constructs an interactive map that lets players see how much changes in land use affect those issues. For example, restoring wetlands in former industrial areas can lower greenhouse gas emissions and pollution, but it also decreases jobs. And changing from high-density apartments to single-family homes reduces housing availability, but expands habitats for birds. Because land use planning is a civic process, players submit proposed changes to simulated community stakeholders for feedback. Stakeholders have different and sometimes conflicting interests, so players are challenged to develop plans that satisfy as many people as possible. To determine how much change each stakeholder wants, players submit different proposals to identify more precise targets for community improvement. Players submit a final proposal when they think they have addressed as many stakeholder concerns as possible. iPlan brings real-world planning practices to mobile devices, allowing players to solve complex land use problems in their own neighborhoods or anywhere in the contiguous United States.
All right. So iPlan's a simulation that we developed, a simulation engine, primarily for high school students, although we've had some use in sort of upper middle school and also some use at the university level. And it's free and online, so lots of people just use it too, and we have no idea who they are, just people that want to try it. But there's a few mechanisms that make iPlan an effective tool for learning about things like climate change adaptation, and land use planning. One of them is that, as the video suggests, right, we take sort of authentic practices of land use planners. So this is things like soliciting stakeholder preferences. This was actually part of the Madison West region where I live, their recent planning process. They solicit feedback. They generate new land use plans. essentially a new scenario for how land could be used. And then they give those back to stakeholders, and they ask sort of for feedback, and these are called stated preference surveys. It's a way for land use planners to say, okay, well, you're telling me what you want is more housing, but I don't really know what that means. So how about if I show you a few different plans, and then you tell me which ones you like and don't like, and then I can use the differences in those plans to kind of calibrate what things people actually want. And so what iPlan does is it takes some of those sort of authentic real-world practices, and then it makes them accessible for kids. So another mechanism that makes iPlan effective in that context is that it takes these kinds of problems and it situates them not in somewhere far, far away, but actually in their own sort of local environment. So they can construct a model, a land use model, for an area that they actually know, that they have some investment in, which means that the things that they do in the simulation will be guided not only by what the simulation tells them or presents to them, but also by their own sort of experience. Right? So you can construct a model anywhere. You can make one for Winter, South Dakota. You can make one for Muscle Shoals, Alabama, Portland, Maine. You can even make one for Area 51 in Nevada if you want. That's not a particularly interesting map, or is it? And then for students, this is really useful because it takes this thing that they're now using in a class. They can use it on a phone, a tablet, a Chromebook, a laptop, whatever. And it situates that learning in their own community, in their own surroundings, and somewhere that they actually sort of care about. And for teachers, this is great because they can use iPlan to construct a kind of custom curriculum unit for their teaching. Using a region that might be the region around the school, or the region where most of the kids live, or a region that they've been studying in class for one reason or another. And then they can make that model and then distribute it to all the kids in the class. They can give every kid their own copy of this exact same model, so they can all sort of try to solve this land use problem in different ways. And so I think the third sort of mechanism that makes iPlan really useful is that it really helps kids see why these are socio-environmental problems, right? Why things like climate change and climate change adaptation in particular, and sort of any aspect of kind of land use planning or most other sort of environmental issues are not strictly scientific issues. They're actually issues that sort of blend science and civics. Right. So, for example, iPlan models bird populations, and as you saw in the video, like one of the things that students will find out, in part because iPlan models robins, American robins, is that if you start constructing things like low-density housing, it will actually increase bird populations, because birds like robins actually do quite well in kind of cohabitating with humans in sort of edge spaces, right? They do really, they kind of thrive in those spaces. But that's just sort of a way of understanding like how robins live and function and interact with humans. That's sort of the science side. But not everybody wants the same things, and that's an important piece of this, right? So that's why we model different stakeholder groups. So for example, one stakeholder might think about birds and think, yeah, that'd be great. Like, I'd love to have more birds around me. Awesome. Other stakeholders might think about the impact that birds are going to have on their friends and say, nope, I don't want to promote policies that are going to cause there to be more birds. Right? This is a little bit of a silly example, but you get the idea, right? That there are things that are contested, right? I think most of us want greenhouse gases to go down, but we also have to balance that against all of the other things that human societies need, right? And the ways in which we can provide them. And so what iPlan does is it simulates for students these processes where people in the community, environmental activists, business lobbyists, community groups, actually weigh in on different land use plans and have very different opinions on how things should work, and often conflicting opinions. And so as they're trying to solve these land use problems, thinking about the ways in which we need to adapt, right, for climate change, for example, they're having to take into account the fact that they have community input and that different members of the community are going to have different priorities for how to address those issues. The simulation has been used by, as of the last time I checked, a little more than 7,000 students since we first released it a few years ago. It's kind of been used all over the US. This map is just sort of where we have actually worked with teachers or in specific contexts where we know it's being used. It's been used much more broadly than this, but these are kind of the places where we have a little bit more knowledge about what's being done. And we've done a lot of interviews with teachers and other sort of studies to analyze learning. And I'll just share one brief little anecdote, which I think is kind of a nice one. We interviewed one teacher who told us, for her students, they often start out using the simulation being really kind of frustrated and kind of like almost like hopeless, right? Like one of them was like, can we ever get to net zero? Like if people have all these different opinions and like it's really this hard to do, like can it even happen? And another one said, like, did you give us this assignment so you could stress us out? Nobody's happy, right? They're talking about the stakeholders, right? Like it can't make everybody happy. And the teacher said, it was actually really good because by the end, students actually felt more confident that there are things that can be done, right? And that's part of why we built the simulation. We wanted to make it realistic enough to show that, like, yeah, we're not going to have any magic wand solutions here. There's not going to be a silver bullet that just takes care of the problem because it's a socio-environmental problem. It's complicated. People are complicated. And you have to actually think about all the different ways that people care about these things as a way to sort of navigate that space. But there also are things that can be done, right? They actually get to see, like, oh, if we make some of these changes, like, how does it affect things like greenhouse gas emissions? How does it affect things like how many heat advisory days we're going to have? How does it affect things like air pollution, wildlife populations, but also things like jobs and housing and sales and the kinds of things that people also care about. I just want to briefly acknowledge that creating iPlan was involved a huge team in addition to funding from the National Science Foundation. But if you want to know more, it is a free simulation. You can use it right now if you want. You can just pull it up on your phone. That's the website. I also have, and I'll put them out. I should have, I guess, put them out earlier, but I have some little cards that have like the QR code on it if you want to just take one home. I also have iPlan stickers, so I'll just set them up here somewhere if anybody wants to grab one on their way out. You guys are welcome to, or take 3. But I will stop there so that if you have any questions, I'm happy to answer them. And again, thank you for having me.